followed by sign.
I'm sorry, not get your name.
After the tone, please state your name, followed by the pound sign.
I'm sorry, not get your name.
After the tone, please state your name, followed by the pound sign. There are 6.
Party in conference. In King you.
Hey, see my...
Oh, I don't.
Hold on. Hear it.
Thank you for calling Duncan Supply Company. Family owned and operated since 1936. Duncan Supply Company is a leader in wholesale distribution of refrigeration, HVAC, and food service equipment with 9 regional branches. Our headquarters are located in Indianapolis at 910 North Illinois Street, just 9 blocks from downtown, with easy access to Interstate 65 and 70. We appreciate your call, and we'll be with you in just a moment.
Larry isn't right.
Did you know the Duncan Supply Company has over 15,000 different items in stock ready for immediate delivery?
Larry.
But just in case we don't have that hard-to-find part or piece of equipment, we maintain purchasing relationships with over 200 different vendors
Ben,
in
call my
the
cell phone if
and
you
refrigeration industry. So go ahead, ask us. We'll be happy to help find and special order that item for you when we return. AAF International has been providing air filtration quality, expertise, and innovation since 1921.
Wow. For future conference calls, always make sure that you never put this line on hold. Got a very nice commercial about services from a particular company. So please, if you have to take another call or get out, just leave your phone open, but don't do the whole thing anymore, because that's what happens. Ben, that was not the right one?
That's not the right one. That was the one. It was the M-line one. Send it to Barb.
Okay. I'm sorry, y'all. Give me a second. We'll get this queued up here. Hey,
Yes.
what if we start off with Randy, and can you run and send it to me, and I'll pull it up that way? I cannot find it.
All right, that.
Malt, I apologize. Okay, we'll go ahead and get started with Randy Teddy on the refrigerator state, and we'll get back to Ben Picker. I'm going to go ahead and share my desktop here in just a second. Okay. Randy, can you see that?
I got it.
All right, perfect. Thank you, and I'm sorry for the interruption, guys.
Again, my name is Randy Teddy. I am the Application/Service Engineering Manager here at Emerson Climate. I'm going to touch basically on the refrigeration as far as refrigerants coming up, different things like that. Just a note of housekeeping: if you're online, please mute your phone so we don't hear a lot of background noise. Things like that. It'll make this much more enjoyable for everybody. Next slide, Larry. This slide basically goes over the alternatives for refrigeration for AC and refrigeration applications. And the way you read this chart, go across the left-hand side, you'll see the pressures or capacity. R410A like refrigerants, and it goes down, which would be the high capacity refrigerants. It goes down to the 404A, 407, 22 like, which would be more of the medium pressure, medium capacity refrigerants. Then it moves into the 134A like, which would be the low pressure, lower capacity refrigerants. And if you were to go across the top, well, let's start from the bottom. Across the bottom where they have the GWP level, is 0 as the GWP up to 2,000. And if you were to go out even further to catch the 404, 457A, up to 3922 as the GWP level. On the chart, you'll see the 410A on the top right-hand corner. And you can see there really is not a tool or a ready drop-in application or a refrigerant for that application as far as the 410A like refrigerant. So we have to go all the way over to the R32 or the 440A, 447A to the very low WP 500, 4 to 600 GWP range. And then as you move down to the 404, 507, as you move in, below the 2,000 GWP, the R22, the 407s, 407Cs, A and F, and then moving a little further past that red dotted line is that we're going to focus on. It was the R440A, 449, and which are less than 1,500, somewhere in the 13 to 1,500 GWP range. And then, like I say, dropping down to the 134A like refrigerant, you can note that the 134A is in that 1,500 GWP line. There is a few available right now as far as the 450A and the 13A, which are closer to the 1,000 to 1,200 GWP range. Any issues on this slide as we move on, or before? All right. EPA has a proposed rule of delisting refrigerants application, and this is a nice what the EPA has suggested as far as a phase-out date or a delisting date for some of these HFCs. The way you want to read this is across the top of the different applications as far as supermarket, condensing unit, steam, self-contained, vending machines, foam, and then auto AC. And then across the left-hand column is different refrigerants. And you want to read this is going across the top left to right. Shows the 404A, 507A. Shows for the supermarket area. It shows that January 2016, the 404 and 507A will be delisted for new applications in supermarkets. And the same with if you go down as far as condensing units, January 26th again is the date. But as you look at this, you'll see that if you were to go to the next column, there's a lot of the blends of refrigerants. You see that a lot of those are being phased out for the supermarkets, but they're not phasing them out for condensing units, standalone vending machines, and so on. And again, exactly sure how many of those refrigerants are really going to be used in condensing units. The odds are majority of those are strictly supermarket refrigerants. Going down the list, we see the 407A and 407F, and you can see that there's delisting for those refrigerants in the market, which basically states you should be able to use those refrigerants to supermarket applications past the January 2016 date. But further down the line to the right, you'll see that underneath the standalone self-contained equipment, there is a delisting date of January 2016 for new equipment. And basically that's how that chart is read as far as the refrigerant and based on the application, they have a delisting date. Any questions here? Move on. This chart, basically, all this is, it's what EPA set out their first notice of delisting. They also gave the industry, OEMs, large manufacturers, Emerson, Coke, one of those, and I think over 120 different letters that were written and sent to the EPA to make suggestions and comments for the listing. In the red areas is where Emerson had submitted suggestions or basically saying what we would rather see than the proposed delisting. See that for 404, 507, Emerson Climate Copeland was okay with the January 2016 delisting for new applications because we have the capability of going to the 407A and the 407F, different refrigerants there.
Can I hang this up?
Go ahead.
Never mind, excuse me.
Okay. And then as we move on down the list there, you'll see that the 404A, 507, underneath condensing units, we require a delay of 6 years. That is due to the fact that condensing units, they're just getting hit by this, the EPA proposal, but also a DOE out there also, requiring the condensing units energy efficiency to be improved by 20 and in some cases up to 50%. That's really not just a drop-in move. There's a lot of work that has to be done to do that. Some may come from refrigerants, some of it may come from compressors, but also a lot of system design that has to be taken into account. To move that out, proposed to move out for 6 years to give the manufacturers a little more time to do work and make condensing units as efficient as what the DOE has requested. And as you move on with the self-contained, we've got a delay for 6 years also. For the 407A and 407F, you see underneath standalone self-contained equipment, we recommended that they do not delist that refrigerant. In the same way with 134A. There's a couple notes on foam. I'm not sure if any of the applicants or the personnel really work with the foaming equipment. But basically, 134A was scheduled to be delisted in January 17, foaming applications. And there's other different chemicals and refrigerants that are used for foaming, so a long list, but they all wanted to, route that by January 2017.
Andy,
Yes, sir.
You said the ones in red is a recommendation from Copeland. Have you received anything back from anybody as a response to that?
We expect, and the DA has to go through all 120 letters and we're hearing is by mid-year 2015 in the June-July timeframe, we should have a response back from the EPA stating what their next step or what their final decision is going to be. So no, we don't have a final number yet, and we probably won't know it until it's published.
Okay.
One thing I noticed, I don't see 407C on this list anywhere. Is that a refrigerant that's going to be safe at this point?
7C.
I think it should be in with the 407A and F. For some reason, it's not there.
I'll have to check on that. Like, it should be within the 407A and 407F range, but it's not showing up there. I'll have to check on that for everybody. Next slide, Larry. And this is just a short chart as far as showing the refrigerant options available in the future. Today we have the 404, the 134A for like the self-contained units and reach-in. And if you were to go down that list on the columns, it shows refrigerant, and then today in the 11-1500 GWP non-flammable refrigerants. And as you go down, it's the less than 300 GWP mildly flammable refrigerants. Down the list all the way to 10 GWP. As you go down as far as the self-contained reach-in column, you'll see there's today 404A, 134A, and we're planning to move a lot of those applications to the 440A, 449A, to the 404. Then also 450A and the 513A, to some of the 134A, if the 134A is indeed delisted. As you go down, back, and there you go. Down that list, you'll see as you get into the mildly flammable and the GWP numbers, there's basically different blends and things that we're looking at evaluating to get to those lower numbers. But like I said, any mildly flammable refrigerant will be an A2 refrigerant. The different regulations and things like that out there that we really need to understand before approved. Go down the list as far as the walk-in, you'll see 404, 407, and it has the refrigerants of 448, 449, 450, 513, and it's the rack application. It shows that's that same option. Now go to the bottom of the chart. Like for the application, you'll see there's CO2. There is some movement within the United States and Canada, as well as Europe, as far as developing racks to run CO2. Walk-in coolers, freezers, propane, some of the HFO blends, which would be the 1234 IF or 1234 ZE refrigerants available at that lower GWP level. And if you go to self-contained units, propane is it's 150, or it's what is the GWP on propane? It's very zero. It is for GWP less than 10, but with the propane right now we're limited to 150 grams per commercial unit. So it kind of limits the size as far as the size of compressor, the size of tubing, and unit that we can use in some of these reach-in or self-contained units. Anything on this slide before we step up? All right. Here's a handy little chart that I use as far as we do some of the training. And this chart basically shows the midpoint, and this is all theoretical data. It shows zero subcooling, 20 degrees superheat, 3 evaporator superheat, various conditions. If you were to go across the top of the list, or on the left-hand side, you see there's a low pressure and then a medium pressure refrigerant. Pressure would be the 134A like refrigerant. You go across the column there, you can see the GWP for 134A is 1430, and then you can compare that to the GWP of some of the other refrigerants as you go down the list. There's the 450A and the 513A. They're around 600 to 631 GWP. The part that's really important here is you want to see what capacity is to different conditions. So if we were to go to the theoretical evaporator capacity, low temp, which is the the fifth, sixth column, you see the 134A as a baseline shows 100%. And go down the list, you can see that the 513A matches the 134A very closely as far as the capacity of the refrigerant. And so if you check the discharge line temperature, you see that the 134A runs a little bit hotter than what the 513A does. You could use a chart like this to basically compare and help an end user or a customer decide which refrigerant they may want to go to as they move forward. And the same on the second chart with the 404A. Shows 404 is a baseline, and then the different refrigerant as far as the GWP levels. One thing we really want to take close account to with the medium pressure refrigerants is the discharge line temperatures, because like you said, if you were to go to the discharge temperature slide or the column, you see that 404A runs about 104 at 2105 condition. But if you go down to the 448s and 449s, you see that discharge line temperature jumps up to the 164 range. So there might be some external cooling, head fans, liquid injections, different things like that that may need to be applied when we're going from a 4A system to 48 or 440. The 407, you'll see where the 4A is pretty much on line with the 448 and the 449. 407C and the 407F are even hotter, in the 170 to almost 180 range.
Brand,
Yes, sir.
is this chart something you can email to us?
Larry, can we email that to the whole group here? Or?
Absolutely. I'll make sure that that's available. These from going forward, all presentations are going to be available to these. So. Let's go next chart, Larry. And just a bar graph that I kind of threw as far as showing the 404A, 134A as baselines, and the red and the blue are basically the evaporator EER, and then the theoretical capacity of the refrigerant. You can see as far as 404A down the line, there's a lot of refrigerants that are showing to have higher capacity in your EER than what 404A is. That's a good thing. One of the things that we're concerned about is that little blue line across the top, where you'll see that the 404A, if you were to follow over to the right-hand column, shows about 140 degrees as far as discharge temperature, whereas the 448 shows the 160 to 167 range. Yeah.
I'm having a hard time following. Somebody's like they're moving on their phones and stuff. It's making it hard for me to hear everything you're saying.
Can we make sure that our phones are muted? I hear some paper shuffling there, so. But to talk a little loud, but basically, can we mute the phones, please?
Hey, for everybody just listening, please mute your phone. A lot of kickback and a lot of paper shuffling and noises. So please mute your phone for us. Thank you.
Okay. So we see the chart shows basically the refrigerants as far as, where the 100% the baseline is, and just a visual comparison as far as the capacity and EER, as well as discharge temperature for each refrigerant. Any questions on that? And like I said, this is basically just a chart of the previous bar graph of a previous chart that I showed. Next slide. Unless there's any other questions, we're going to roll it over to Ben Picker.
I will get loaded right now.
All right, everybody. While everybody's online yet, the new 93-11, which is the approved list, refrigerants and lubrications approved by use in Copeland compressors, that has been updated and should be, the latest version should be available online right now.
I have it for you. I'm looking at it right now, and you have 448A, 449A. You have it as similar to R22, not R4. So I was wondering what the logic was behind that.
Yeah, that's a question that came up within our walls also. The way I look at that is if you go through the let's say the excuse me here, I don't have that chart in front of me. The 448, you said it's like the R22. And if you were to say any that is 22 like would be more of the mid pressure temperature refrigerant.
But when the manufacturers really have come to 404 with those products.
Right. Yeah. It's confusing. If I were to put all the refrigerants that the 448, 449 were compatible to, I would list the 7 different refrigerants in that column.
Right. Lower discharge temperatures than R22. R22, the last chart was like 185. Those are in the 160s. It's misleading, I think.
Right. We're still working internally as far as trying to decide what to put that's in similar to column that even to eliminate it altogether because it just leads to more confusion.
Maybe it's 22/R404.
Okay.
Okay, Ben, are you ready?
Yes, I'm ready.
So, a lot of you guys have sat in the different training sessions and had many different Emerson people come and talk to you and tell you to sell more units or try to get you to sell more units. And the last few years we've done quite a bit with trying to promote the X line and the newer F line scroll units. And we really let the small M lines kind of sit by the wayside, and we really haven't done anything with them as training or promotion goes over the last few years. So just wanted to sit out here and kind of go through a refresher course, or even new training if you're not really familiar with them to begin with, just for some of our M lines. So what our lines are, it's these are fractional horsepower units. They go all the way down to 1/6 horsepower up to about 7/8 or so. So it's anything that's under 1 horsepower or within our M line range. It's a very diverse product line. We have these in cooled and water cooled. Also have the Cobat condensate base. We have that in 3 different sizes that are available. And then, like all of our other units, we've moved to the electronic pressure control on all these units. You can go to the next one. Next one, Larry.
Yeah. Come on. Hold on a second, Ben. Boy, this is a good day for this stuff.
technical difficulties. All right. So within our M line, we have we call the value add product line. What this is, we add the filter dryer and sight glass to the units. All in all, we've got about 60 different models available between all different specific model family or the model groups. They're available the 1/4 up to 7/8, all the different refrigerants. One thing to really keep in mind is the bill of material number. When the 7 is in the middle digit of those last three numbers, that means it's the value add, which meaning the filter dryer and the sight glass. One of the differences is the first digit. It's going to be either a 0 or a 2 for the most part for our standard units. And the difference is between the 07 and the 27 models really comes down to the pressure control. A lot of these units here operate just off of thermostat control. They really don't have pressure controls on a lot of them. In those cases, we offer the 27 materials. So they're the same layout, same components as the 07 models. They just don't have the pressure control. Without the pressure control, they're not able to be listed, but have all the same other components like fan guards and conduit and electrical boxes, all that stuff. So as UL type goes, they're essentially the same thing. The only difference is the pressure control. You go aside. The different, what we call the coat app, which is our condensate-based form. We have that available in 3 different sizes, most of which here is what we call our narrow coat bath. What this is more or less a kind of a direct replacement for gray base. So if you have somebody that's using the Tecumseh gray base, you can offer these as more or less a direct replacement for those. With them in 404A and 134A models. And these range from about 1/4 horsepower up to a 1/3 horsepower. These are smaller models. They do have an optional receiver, so you can get it with or without the receiver. So whether it's a cap tube system or a TXV system, we have options for either of them. And then they do come with a power cord already installed to them. So these are meant to be just put in place and then plugged into a electrical outlet. All right, you can go to the next one. So comes to the M lines, looking at the model nomenclature, a few key things can help you identify what the model is or how it's equipped rather quickly. Now, if you go to the bill of material side, all the way over on the right-hand side, we talked about that a little bit already. The digit being a 7, that's our value add model. And like all of our other models, the 4 and the 6, those are specials. So the model you see that has the 4 or a 6 in that middle digit is we've set up for OEMs.
Great.
Now, that doesn't mean that you can't get it. Some of our units are available through wholesale. In many cases, sometimes OEMs will cease servicing models and they won't have available, or a contractor will come in just looking for a specific model at the wholesalers. And these units are available to you to order. They most likely will not be stocked items. You'll probably have to call customer service and get pricing and availability. But they are available to you. Another thing to keep in mind also is with the new G regulations, a lot of these units are, becoming, equipped to be more efficient. Started putting ECM fan motors on a lot of our units, especially on these small M lines. So in that little section there, that first digit, if there's an E in that digit, that means that unit has an ECM fan motor on it. So there's a way to differentiate. It's on there and let you know what's on the unit. Good. Are there questions up to the point? Okay, so Larry, we can move on. So talking a little bit about the value add units. We talked about it. They have the receiver, or I'm sorry, the filter dryer and the sight glass put on there already. Really, what the units are meant for is to allow a contractor to go through a service, and instead of replacing the compressor, to give a little bit more value and a little incentive to replace the entire unit. We found in the past is some will go through and replace a failed compressor, and shortly thereafter they have problems with the fan motor or another component within the unit. So we really stress if somebody comes in looking for one of these small compressors, these small A-line compressors, it's really better off for them to go ahead and replace the entire unit. And we'll go through a breakdown of that here in just a little bit. You can go to the next slide, Larry. So what we've done is we kind of took a look at what it takes to replace a condenser or a compressor versus replacing an entire condensing unit. So, a compressor fail, a contractor I would expect would not replace just the compressor. If they do the job right, they're at least going to add a filter dryer, replace the filter dryer on it, and also any other stuff, the fan motor. Those are things that should be done. Things to get into the travel costs and labor and whatnot. So if you go through all of the parts, all the equipment, all the labor, the time it takes to do it, what we generally find is the contractor is often dollars and time ahead by replacing the entire condensing unit versus just the compressor. Just cost that they put to it, about a wash, but when you consider the labor savings, really a much higher profit margin in it for the contractor by doing the entire unit because it takes a lot less time.
Where is this information located?
No, this is Copeland.
So you can go to the next slide, Larry. All of the information that we have on M-line units, of course, is available in PI. Now, within OPI, we have a cross-reference tool for that here for condensing units with some Tecumseh and Danfoss units in here. So if someone's in with the Tecumseh or a Danfoss unit, you can easily just go to this section of OPI and get cross-reference over to the Copeland model. Go to the next slide, Larry. For models that are not in the cross-reference, because that does have a tendency to get time might not be the most accurate or up to date. You can always use the unit search tool within OPI, and from there it gives you many options for searching. You can, if you just know the capacity, you can search by capacity. If you have any restrictions on the length, width, or height of it, you can put that in this search tool as well to help you find an appropriate cross to an existing unit. But in any case, we really do recommend when somebody comes in looking for one of those small compressors, we really highly recommend, swapping out the unit, the entire unit instead of just the compressor. I think that last slide, Larry. Go there. So, are there any questions on this? And we went through quick.
Oh, yeah.
Okay.
All right.
Randy and Ben, thank you. And everybody, I thank you for joining us on the second CTS WebEx. This was recorded and will be available next week. Until next month, everybody have a happy Easter, and we'll talk to you then. Thanks.
Bye.
Has disconnected. This call will now end.